Hello everyone, my name is Ashwajit Manikrao Raut. Currently I am in second year, third sem, pursuing BTech from H1 Rural Education Society, led Shri Bapurauji Deshmukh, College of Engineering, Sevagram, Wardha. Okay, in that video we'll discuss about the Mealy machine. So in that video, what is Mealy machine and one example on that Mealy machine. Okay. Before going to know about the Mealy machine, so first we discuss recall the things. Finite automata. In that finite automata are of two types, without output or with output. In that without output, DFA called as deterministic finite automata or non-deterministic finite automata, and non-deterministic finite automata with NFA with epsilon. In that after with output, in that with output, in finite automata, Mealy machine and Moore machine. Okay, so in that Mealy machine, discuss about the Mealy machine. So in that finite state machine there are two types machine that generates the output, Mealy machine and Moore machine. In that Mealy machine, Mealy machine defines a Mealy machine is a finite state machine whose output depends on the present state as well as the present input. Okay, in that two points are important, present state and present input. So output is depends only present state as well as the present input. Okay, so going to next, it in that Mealy machine it can be described by six tuple. Previously we seen in the DFA and NFA only have five tuples, but why in Moore machine and Mealy machine have six tuples? Because Mealy machine and Moore machines generates output, and DFA NFA not will not generates outputs. So it can be described by six tuples. Q summation O is or is also called delta, and del x q naught. These six tuples indicates that Q is the finite set of states. Summation is the finite set of symbols called input alphabet. 0 or also known as del is the finite set of symbol called as input alphabet, output alphabet. Del is the input transition function where del equal to q into summation is equal to q. Q is the finite set of states. X is the output transition function where x equal to set of finite state equal into summation called as input alphabet is equal to 0. Q is the q naught is the initial state or starting state from where any input is processed. Okay, in Mealy machines, discuss one example on that Mealy machine. So Mealy machine, this is the transition table of Mealy machine or state table of Mealy machine. We will seen in Mealy machine. Mealy machines depends on output depends on the present state as well as the present input state. So in that, when input equals to 0, there is state output. When input equals to 1, state and output. Okay, A is starting states. We in that have there are with the help of transition table we can draw the transition diagram. As you see, in that we have four states. Okay, let's draw the four states A, B, C and D. Okay, where A is a starting state. Okay, when input equals to 0, A is going to set A to B and generate input when input is 0 and output generates x1. Okay, uh, also in when input equals to 1, starting A states going to C as we see C going to C. Okay, when input is 1 and which generates its C itself and generates the output is x1. Okay, after that B is when input is 0, B is going itself and when input is 0 and output generates x2. Okay, in that B, when input is 1, B state to D state going. Okay, when input is 1 and generates the output is x3. After that C. Okay, C is going to C to state D when input is 0 and it generates the output is x3. Okay, in that also in when input is 1, C is going itself input when input is 1 and it generates the output is x1. Okay, after that D, when state D starting state D, D is going when input is 0, D is going to D itself and when input is 0 and it generates the output is x3. Okay, then next when input is 1, then D is going itself and when input is 1 and generates the output is x2. As we see in the transition table, we can draw easily a state diagram or transition diagram with the help of transition table. Can easily draw the state diagram or transition diagram. Okay, thank you.